Good morning, respected panel members, faculties, and my fellow students. Today I am presenting our project titled AI powered fraud detection, which focuses on using artificial intelligence and machine learning to identify, analyze, and prevent fraudulent activities in financial transaction systems. Problem statement motivation. With the rapid growth of digital payments, UPI transactions, online banking, and e commerce, the volume of financial transactions has increased exponentially. However, this growth has also led to credit card fraud, fake transactions, identity theft, account takeover attacks, money launching attempts, and traditional fraud detection systems are mostly rule based, meaning they rely on predefined conditions. They cannot detect new or unknown fraud patterns. They generate a large number of false alerts. They are expensive to maintain and update. Fraudsters continuously evolve the techniques, making static systems ineffective. This challenge motivated us to develop an AI-based adaptive fraud detection system that can learn from historical data, detect anomalies automatically, adapt to new fraud patterns over time. Project overview and vision. The AI-powered fraud detection system is designed to analyze transaction data and intellectual classify each transaction as legitimate or fraudulent. Our vision is to create a system that works in near real time, scales to millions of transactions, minimizes false positive, assets analyzers, and decision makers. The system is applicable in banks, financial institutions, payment gateways, e commerce platforms, digital wallets, enterprise fraud monitor solutions. Objective and success metrics. The key objective of the project includes high fraud detection accuracy, reduced false rate, faster fraud response time, improved customer trust, scalable and modular system design. Modular system design. Success is measured using precision and recall, F1 score, ROC curve, and confusion matrix analysis. System architecture technology. System architecture technology. Front layer. கீழே தள்ளு. Developed using React plus TypeScript, style using Tailwind CSS, built with wide and fast performance. The UI provides transaction input, upload fraud protection visualization, risk code dashboards, interactive chats, and insights. Machine learning layer. The intelligence of the system lies in multiple ML models such as logistic regression, baseline classification, random forest, assemble learning, XGBoost, high performance boosting, isolation forest, anomaly detection. Each model contributes to detecting known fraud patterns, identifying unusual transaction behaviors, improving overall prediction accuracy. Visualization layer, chat.js for graphs, optional d3.js for advanced analytics. End-to-end machine learning workflow, data collection, public datasets like Kaggle, credit card, and fraud dataset, synthetic fraud for testing, data cleaning and preparation, handling missing values, removing outliers, normalizing transaction amounts, encoding categorical variables, feature engineering. Important features includes transaction feature, average transaction amount, time-based behavior, location and device patterns, model training and evaluation, supervised and unsupervised models, hyperparameter tuning, cross validation. The impact of AI-powered fraud detection system is both practical and significant, especially in today's digitally driven financial ecosystems. First, the system plays a crucial role in reducing financial losses by identifying fraudulent transactions at an early stage. Financial institutions and platforms can prevent unauthorized payments before money is transferred. This proactive detection minimizes direct monetary damage and reduces the cost involved in post fraud recovery. Second, the project greatly enhances the user trust and confidence. When customers know that an intellectual system is actively monitoring transactions and protecting their accounts, they feel more secure while using the digital banking and online payment services. This trust is extremely important for customer retention and long-term platform credibility. Another important impact is automation of fraud detection process. Traditionally, fraud analysis requires large teams of analysts manually reviewing suspicious transactions. Our system reduces high our system reduces high transactions, allowing human experts to focus only on critical cases. This improves efficiency and reduces operational workload. The system also improves decision making speed since the model provides probability scores and real-time alerts. Organization can respond immediately to threats instead of reacting after the damage has occurred. Fast decision making directly translates to better fraud prevention. From a technical perspective, the project demonstrates how machine learning and scale to large data set. The architecture is designed to handle growing transactions and volumes, making it suitable for real world deployment in banks, payments, gateways, and e commerce platforms. Additionally, the project supports data driven insights and analytics through a visual dashboards and trend analysis. Organization can understand fraud patterns, peak fraud periods, and risky behavior. These insights help improve policies, strengthen security rules, and restrain model efficiently. The system also promotes ethical and responsible AI usage by using anonymized data, focusing on behavior based on analysis rather than personal identity. The project ensures fairness, privacy, and compliances with data protection awareness. Finally, from the academic and the learning perspective, the project has strong impact and skill development. It bridges the gap between theory and practice by combining machine learning, front-end development, data analysis, and system design into a single real-world system. Overall, the project showcased AI-driven delivery measures, valuable enhances, and security and build trust in digital financial systems. Data pre-processing techniques. Key pre-processing steps include handling missing values, normalization, outlier detection, encoding categorical features. Feature engineering approach. Important features include transaction frequency, transaction amount behavior, time-based patterns, user behavior trends. Handling imbalanced data. Fraud data sets are highly imbalanced. We address this using resampling techniques, cost-sensitive learning, evaluation beyond accuracy, model training process. Training includes supervised and unsupervised learning, hyperparameter learning, cross-validation, ensemble techniques, model evaluation metrics. Models are evaluated using precision, recall, reference score, ROC, AOC curve, and fusion matrix. Fraud prediction and risk scoring. The system assigns a fraud probability score, flags high-risk transactions, supports automated alerts. Visualization and analytics dashboard. Visualization helps in understanding the fraud trends, monitoring transaction behavior, analyzing model performance. Security data and data privacy measures. Data anonymization, secure data handling, ethical AI practices, and compliance with safety design. Challenges faced during development. Some challenges include imbalance in dataset, feature selection, false positives, model overfitting. This was addressed using ML best practices. Ethical AI considerations. The steps is designed to be fair and unbiased, transparent, explainable in future versions. Real world use cases scenario. A suspicious high value transaction is detected. The model assigns a high risk to the system flags the transaction. Prevention action is triggered. Scalability and performance consideration. Architecture supports large scale transaction volumes, real time processing, API based integration. Future enhancements include real time API detection, deep learning models, explainable AI, and cloud deployment. Learning outcomes. To the project we gained ML pipeline experience, fraud domain knowledge, full stack development exposure, data visualization skills. Project impact. The system reduces the financial loss, enhances users trust, improves transaction security, automates fraud detection. Most important outcome of the project is the ability to balance security with user experience. While fraud detection system must be strict, they should not inconvenience genuine users. Our approach focuses on reduce false positives, ensuring that legitimate transactions are not necessarily blocked, thereby improving customer satisfaction and trust. From a technical perspective, this project strengthened our understanding of machine learning pipelines, handling imbalanced data sets, model is evaluated, and the system datasets integration. It also provides hands-on experience in connecting AI models with a modern front-end interface, making predictive understanding and actionable dot visual insights. Beyond technical skills, the project highlights the importance of ethical and responsible AI by prioritizing data anonymization, fairness, transparency. The system aligns with real-world compliances and privacy requirements, an essential consideration for financial application. Looking at the project has a strong potential for real-world deployment with enhancements such as real-time APIs, deep learning models, explainable AI, and cloud deployment. It can also evolve it can also evolve an enterprise-level fraud detection platform capable of handling large-scale financial systems. In summary, the AI-powered fraud detection project is not just an academic experience.